This book of abstract algebra by Dummit and Foote doesn't really need any introduction. It's already so famous and many students rely on it. I did for my own PhD comprehensive exams in algebra, so I know that it's a really good book. I got a lot of use out of it, and I just wanted to share what I think is necessary or maybe just useful to get the most out of the book, because a lot of students get recommended to this book when they ask for if they go on a forum and they ask what are the best books in abstract algebra, or what is a really good book of abstract algebra. So I just want to share from my perspective what I think you can get out of this book and what I think you should focus on. And even though the book is huge, it has about 2 years worth of material in the book, I think what I'm about to say is applicable to every section, regardless of what section you want to focus on. And I'll just use the very first section of the first chapter to make my point. So if we just look at the introduction to groups, I think that's page 16. Yeah. So it gives you basic axioms and examples, and those are very useful, of course. And it will go into a basic proposition. So this is not something uncommon. You would see it in any elementary treatment of groups at the beginning of most textbooks or lecture notes in abstract algebra. And there's a second proposition, also fairly commonplace, that they give together with its proof. And then they define what the order of an element in a group is. And finally, they close with telling you what the multiplication table of a group is like. Now that's not a lot of material. That's about 5 pages. And I made that comment about it only being 5 pages, not as a criticism, but I just wanted to show that they really only went as far as introducing the basic structure of a group. And students who are not as experienced, maybe they're very early on in their exposure to abstract algebra, might think, oh, okay, well, as long as I understand these things, I'll be good. What I want to say is these 5 pages are really easy to understand. You could probably go through it in about half an hour or maybe an hour tops. But when you get confronted with non-standard questions on an exam, or like the kind you would find in a comprehensive, like at the PhD level, there will be a very different situation for you, because it won't look like the very simple examples that you got in the chapter, like earlier on. And you need to do something about that. You need to give yourself exposure to different scenarios. And I want you to bear with me as I talk about the exercises, because I want to illustrate what exactly you get from them, or at least a couple of the things that stood out to me. So looking at the first one, well, the first 2 questions, you could see they have binary operations and they want you to say if it's associative or commutative. And someone might be tempted to skip over that because it looks like it could be trivial, but it's actually not that trivial. It's worth going through the motions to determine whether these operations are actually commutative or associative, because you want to get out of the mode of thinking in terms of adding real numbers or adding integers or multiplication with elements of those sets, because what you want to do is get accustomed to generalizing those operations. That's what the whole point of abstract algebra is. And in order to do that, you have to go through questions like these. It's really worth it. And if you look at question 5, it's asking you to prove that for all n greater than 1, the group of integers modulo n is not a group under multiplication of residue classes. That might give a student pause when they first see it, but when you play around with a couple of examples, you realize that the residue class of 0 doesn't have any multiplicative inverse in any of these sets, so therefore none of them are groups. Just because of that observation, you can just write that down. You could say, okay, these things are not groups, and that's how you prove it. Now, question 23 is another good one. Remember earlier, they just gave the order of an element of a group. They just gave a definition. That's all they did. But here they're asking if n is equal to st, a product, st, prove that x power s is equal to t, where the order of x is actually n. Now, a student might be tempted to treat it just like indices. X power s, raise it to power t, show that it's equal to the identity, and then you're done. But you're not done, because you need to say if there's an element that's less than t, you need to show that it doesn't give you the identity. So in other words, t is actually the smallest such power that would do that if you apply it to x power s. So this kind of experience will only come if you allow yourself to face questions like these. Otherwise, you'll face it for the first time, likely in an exam, and the experience will not feel good. Another question that I like a lot was question 31. It says, prove that any finite group of even order contains an element of order 2. And they give you a hint. They tell you to consider all the elements that are not their own inverse. Now, all you really have to do is pair up those elements with their inverses and realize that there are only two elements left over, the identity and another element. And since the identity is its own inverse, the other element will also be its own inverse, and that element squared is going to equal to the identity. So therefore, that element has order 2. Now, the way I just said it probably sounds very fast, like I didn't think about it at all, but when I actually tackled this question, it took me over half an hour to figure that out. And I don't need to tell you that spending half an hour in an exam on a question like this is not good. It's not good for my chances, my performance on the overall exam. But it's not just about the mere task of finishing an exam and getting a grade. What I want to say is more about how deeply you understand the material and how comfortable you get with groups. You won't get comfortable just by going through the stuff that they give you early in the chapter. That stuff is good and that stuff is necessary, but you need to be able to apply it in situations that don't look very standard. And these questions will do that for you. And I know that professors will often tell you that math is not a spectator sport, or they might tell you doing the questions is doing the course. And maybe you might feel like you heard it repeated too many times. But what I'm hoping is that what I said to you in this video doesn't sound so repetitive, because I showed you a couple of instances where I got really nice insight via tackling some problem. And perhaps by me showing you that, you'll be motivated to go through all of these problems yourself when you're using this book. Because I feel like, look at this section, it has 36 problems. That might seem like a lot, and in some ways it is, but I don't want you to think that I read the chapter and maybe if I just go through the first 10 problems, I'll be fine. You won't get as much as if you go through the other problems, if you go through all of them, ideally. And I think most students won't be going through this book cover to cover the first time. You'll likely be picking out sections according to your course or according to your exam. And in that case, you could probably go through every exercise in each section. If I had to make a comment about this book, like characterizing it, I would say this is a book that leaves a lot of the theory to the exercises. And it's a good experience because it's very immersive. You're not passively reading somebody else's proof and just understanding what they did. You're actively thinking about it. And the last thing I want to say is that when you're going through this book, I think you should be patient with the book, be patient with the material, and above all else, be patient with yourself, because not all students learn at the same rate. Not all students make the same mistakes at the same times, and not all students get insight into proofs and solving other problems in the same way and at the same speed as other students. So if you find that you're making your way through the book and it's going really slow, talk to your professor, talk to another student, ask a question on a forum like Math Stack Exchange or something, but fight with it. That battle is worth it. It will teach you a lot more than just what you read in the chapter. Actually, when you go through these exercises, for some chapters, you might feel like the only learning you did is while you were doing the exercises. And I think that's the point of this book. So what I want to say is that doing all of the exercises in whatever section you're interested in is the way to get the most out of abstract algebra by Dummit and Foote.